Today I had my farewell party, therefore this is hopefully my last speech I do. This is a result of a work of approximately 10 years. I searched for flexibilities in logistic processes because my opinion is that industrial companies with their flexibilities in production, and in our case in logistics, are able to support a renewable system of energy. This program was supported by the Bavarian state with 2 million euro for 4 years, and Linde, as a partner in this project, spent additional approximately 2 million. Therefore, it's a huge program which with a lot of topics. We had some methods, cloud-based sensor data fusion means we searched for data in the production sites, in the forklift cars and so on, and we used them, I used them for energy purposes. Then cooperative localization and perception, very important for our case, because we have to know where the forklift cars are, where they are and what they are doing in the next time. And we used artificial intelligence and machine learning methods to do forecasting to operate this forklift cars. And we developed a lot of applications. Predictive maintenance is one thing, because if you have the information about operation of a forklift car, then you can use this information for predictive maintenance works. Then very important and central point of my research, battery management and charging methods. And the central point of my project part was energy management and energy flexibility. This project took 4 years and will last at the end of this year. This picture shows the central problem of renewable energies. You see the red line, that's the demand of a company, electricity demand of a company, and the yellow line shows the sub-production of energy out of renewables. And what we can see, we always have a deviation between production and demand of electricity. And that's the central topic if we implement a huge amount of renewable energy in our system. We have to solve the deviation between demand and production. And we have at least three top possibilities to do that. One, and the main, is storage. And the second is to handle the customer, to manage the customer load. And third point is a decentralized production, because decentralized production is able to stabilize a grid decentralized if we don't have centralized options. Storage and customer load are flexibilities in companies. If you look at this forklift car, we have a battery in it, and if we look at this battery, it's a storage. And if we operate this battery not just for logistic purposes, we can use this flexibility for operating the grid. And that is the point we looked for in this business case. An important topic is virtual power plants. I published a paper 10 years ago. I worked for a French company, Altron, and we did a project with a virtual power plant in an international team. And essential point is this picture. What is the meaning or the definition of a virtual power plant? There are existing different definitions. One is this, and we published that. And how can I get back? On the one side, we have market opportunities, trading market, risk premium capacity, OTC contracts, whatever. everything are marketed. These are marketed opportunities, and we have real options. Real options means that you can fulfill if you make a bid. Also you can bid at the market, you can bid everything if you are, and then you can trade with that. But if you want to be a part of the market, an active part of the market, then you have to be able to deliver this electricity. And that is what we looked for. Real options are storages, in this case, trading derivatives, industrial flexibilities, load curve, and so on. To make it a little bit more practice, if you look at the electricity, then you have a price, of course. This price is time related. This is shown by the time profile of the price, and we have a load. And if you look at the balancing market, then you have a certain price at a certain time and at a certain load. And the same you find in the distribution grid. A company like Linde is connected to a distribution grid, and there we find the same situation, that you have a certain price or costs of electricity for electricity transportation at a certain time and a certain load. And you have to match that with the input data, in our case, of the logistic. There you find the same. In a company, you have a flexibility at certain costs. If you influence the logistic process, then you have costs, and you have a certain time when you can do that, and you have a certain load which you can offer. And if this is matching, that is a point in this picture. If this is matching, then you can use this electricity. Yeah, what have we done? I will not go deep into this picture or in this process, but we searched for a reference network which was used in a lot of cases in Europe. It's a characteristic grid, part of a grid. And what we did is we made a forecast on the developing of electricity production out of renewables, wind and sun. This additional production in the grid leads to additional loads, means you have to invest in this grid. We did the same with the load. We looked for car charging purposes and for heat pumps or the heat processes. And this also leads to an additional load, means additional investment needs in this grid. The first what we did is, if we increase this load, we look what is happening in the grid. And just one point, you are allowed to be 10% away from the offered voltage in the grid. The rules in the European network allow to be 10% away. And if we look at this green point, and that is 2015, with our additional load, we have a problem. The technical problem is you do not know where it happens, because electricity is flowing in the grid where the resistance is the lowest. Means we have to invest in this grid. There are 3 points which are not independent. The first point is the grid costs. Also, if you have the grid and you have to invest, then the costs are increasing. This is the length of the grid, labor costs, outage costs, and whatever. And we have the system service costs. Also, you have to operate this grid. You have to offer services, and we have the cost of redispatch, a very strong increasing topic in European grids because of the very often changing offer of electricity out of the renewables. You need control energy. This is also an increasing point. and balancing energy costs that are the system service things. And you have the cost of flexibility. We looked at a certain process in a very concrete company. It's a production of Linde material handling. This is a producer of this forklift cars. And we did a very deep research on possibilities to change these logistic processes, and we searched for the flexibility of these batteries, and this of course leads to costs, because if you deliver late, then you have to pay for it. What is the central point in the grid when you invest? I was responsible for a grid in Hungary for 5 years, the grid of Budapest, and therefore I had to plan the investment. And what you are doing is to make a forecast for the load for the next 50 years. Because if you dig a channel in a street and put a part of grid in it, then you have to live with that for the next years, because it's not possible to open the grid. To open the street again, or it's not so easy. And therefore you plan a grid for 50 years. This leads to this certain green point. Then additional load is coming by renewables, by charging points and whatever. And this leads to this red point. You come to this load earlier than you thought. And therefore additional investments are needed. And the central question is, can you influence this red point by using flexibilities, and therefore, and as a result, reduce the investment needs in the grid? That is what this picture shows. You can, the red line is the flexibility. If you are more flexibility, of course, costs for flexibility are growing. Then we have a certain potential of investment. Depreciation is the red, the blue line, and of course, very simple problem, you have an optimum. And we developed a model to calculate that, and the model leads to this result for this certain grid, and a very concrete case in a company. It's possible, although we have a potential to save 700,000 euro in this grid. That's a huge amount. If we go back to this picture, we see that we can save approximately 30% of the investment. Or we can have 10 additional years with this grid. Although the flexibility is able to solve an energy problem or an energy system problem, and there is a huge potential for companies, and that is why I'm happy to be here today, because it could be a point of sustainability to search for flexibilities in your companies. Yeah, although we developed a model how to deal with that. It's not so important. Come to my summary. It's very important because Linde invested in that business case a lot of money. I'm not allowed to talk about details, but they invested in the blockchain technology, and it's a very interesting solution. I come to the summary. Industrial flexibilities are competitive in balancing energy markets today. This is operating business today. Industrial flexibilities have the potential to avoid grid investments. It's theoretically possible, but with the German and European regulation, mainly with the German regulation, it's not possible to do that. It's not possible, it's not impossible, you can do that, but the grid companies don't have any motivation to do that, because for every investment they get money, and if they reduce it, they just don't get the money. Yeah, however, regulation still needs to developed. Thank you for the time. Any questions?
We have the roundtables for this.
We have the roundtables.
Like,
okay.
after the summary. Thank you.